All right, so let's go through this practice test, see how you did. So number one, it wants the restrictions are on the domain, right? So the domain is only going to be affected if the denominator, if something is undefined. And in this case with a rational, it's only if the denominator equals 0. And so typically we would start to look at how to factor this quadratic. This quadratic, however, cannot be factored. And if we look at the graph with our graphing calculator, we see that it does not intersect the x-axis. It is way up above the x-axis. So since there's no x-intercepts, there are no zeros, which means there are no x values that would make this denominator 0 because of the type of quadratic it is. So there are no restrictions. Okay, so this one was definitely a special case because there's no restriction, so our domain is from negative infinity to positive infinity. But remember, usually what happens is this denominator can be factored, and whatever the 0, whatever this quadratic would equal would be your restrictions on the domain. For example, if this was a minus 35 and you're thinking of two numbers that multiply to negative 35 and add to negative 2, that would be negative 7 and 5, which would mean your factors are x minus 7 and x plus 5, which means your x values could not equal positive 7 and negative 5. So if this was a negative 35, then C would have been your answer because we'd have to skip over negative 5 and we'd have to skip over 7, and this is what our domain would look like. But again, that's only if this was a negative 35, then it would be able to be factored. So make sure you're looking carefully at these quadratics and working through them carefully. Looking, again, if it can't factor in the denominator, I would recommend graphing it on your graphing calculator. If it doesn't intersect the x-axis, then it has no x-intercepts, no zeros, so no restrictions, okay? The other type of restriction on our domain we could see is if there was a square root. So typically square roots, it is greater than or equal to 0, but because the square root's in the denominator, we can't have the or equal to, so it's just that this expression cannot equal 0 underneath here, so it's just going to be greater than 0, right? Because typically it's with the square root, this expression has to be greater than or equal to 0, but because it's in the denominator, we can't have the or equal to, so we just keep it greater than. So x has to be less than 4. Look at how when we divide both sides by the negative, we had to switch the inequality sign. So x has to be less than negative 4, so A is our answer. One-to-one functions have to pass the horizontal line test. Quadratics fail the horizontal line test because of that U shape. If you drew a horizontal line, it would intersect it twice. So D is not a one-to-one. So circles with endpoints, first we need to use the midpoint formula to find the center. So we see here we're finding the midpoint formula. Remember, you just add the x's, divide by 2, add the y's, divide by 2. So that is our center. Right off the bat, you guys, remember you have multiple choice answers. You can go through and start eliminating. This circle does not have a center of 5, 5. Neither does this one, and neither does this one. So right off the bat, we can eliminate options A, B, and D because they don't have the center of 5, 5. Also, when you have the center, you have to plug it in with a minus sign or the opposite sign. Since both these are positive, we're going to need to write it with a negative. And so because of that, we can also eliminate C. So you see, without even finishing up or finding the radius, we've already eliminated 4 out of the 5, so we know our answer is E. Now, of course, we can double check our answer by plugging in the x. If we plug in the center here, with x minus 5, y minus 5, and then equals radius squared, you could take 1 point and plug it in for x and y, so the 9 for the x, the 8 for the y, and then solve for r, and we get r squared is 25, so that just confirms that E is the correct answer. Okay, remember, feel free to pause to go over any questions if you need to. So the domain of this graph, so we're moving left to right. First of all, I see arrows on the very left and arrows on the very right. So I know my domain's going to start with negative infinity and end with positive infinity. Now in the middle, I have to make sure every x value is accounted for. So the first area that I'm going to focus in on is right here is x equals -2. I see that there is a closed circle at x equals -2, so I don't have to break up my domain at all for -2. The next spot that looks interesting is +2. When I look at +2, I don't see any closed circle with an x value of +2, so I know that that's going to have to be a break in my domain. So I know that it's not this guy, I know it's not this guy, I know it's not this guy because it should start with -infinity. These guys have a break at 2 and 2 here, but look at this. This has a break of -2. We already said there was not a break, so I can eliminate that. And without even finishing the problem again, because I'm using some of my test taking skills, I know my answer is letter A, but I'll just make sure the last break in the graph that I want to look at is here. However, again, closed circle at 3. Even though there is a jump from this graph to this graph, we have a closed circle somewhere along this x value, so the domain is okay. The only spot in the domain that's opened is at +2, so we only need to skip over +2 in our domain. Range would be very similar, looking how far down, how far up. I do not see an arrow that's pointing down at all, so I know my range will not start at -infinity. So these guys are not going to be answers because I don't see any arrows pointing down forever. I see arrows pointing up forever, so I know the last part of my range should be +infinity, which means D is not going to be the answer. And now I'm just going to check. Does this make sense? Does the lowest this graph go is -6? Sure does. We have a point right here at -6. And are we, is there a closed point everywhere else? Well, there's an open circle here, but a closed circle here, so we're good there. Closed, open here, but closed here, so we're okay. Open, closed, and everywhere else we're all taken care of. So our range is from -6 and up to +infinity. Awesome. Continuing on, writing the equation of a line that goes through this point and has a slope of 0. So anytime you see that slope of 0, you're thinking of H-O-Y, hoy, right? So slope of 0 means this is a horizontal line. It has a slope of 0, and the equation is going to be y equals some number. And in the point, we see that y is -5. So our answer is B, y equals -5. Number 8, so we have a parent function of 1 over x. It's a rational. And we go from this basic parent function to here. So we're looking at what transformations are occurring. So remember, any value that you're adding or subtracting with the x is going to be a horizontal. So here we have left 7, because again, anything with the x, it's a horizontal, and you do the opposite of what the sign says. And then anything outside is going to be a y, so this one is down 6 because it's a -6. So we have down 6 is the only one of these that occurred. If we're looking at perpendicular writing a point, so here's a point, we need to be perpendicular to this guy. So in order to identify the slope, first you need to solve for y. So subtract the 4x, divide by 3. The slope of this line is -4/3. We need to be perpendicular, so we're the opposite reciprocal. So negative to positive and then flip. So +3/4. Pair that with this point and we get point slope form. All of the answer choices were in point slope, so we knew we could stop there. But remember, it might have been that the answer choices were in slope intercept, so you would have to solve for y. Next, which of these represents the graph below? So we're looking at our zeros. So this one kind of snakes through A, and so we know it's going to be a cubic. It's going to be cubed, or multiplicity of 3. And since this is a negative, we're going to write A plus 3 and then cube it. This one is a bounce, so it's to be a multiplicity of 2. Since B is positive, it's x minus B, and we square it. And so A is our answer. To find the vertex of a quadratic, we can use opposite b over 2a. You could also complete the square, but this one would have been harder to complete the square. So we could just use opposite b over 2a. This gives us the x value of our vertex. So we would do opposite of -12 is +12 times 2 divided by 2 times 3, right? A is our 3 is our a value. And so we get the x value of our vertex is 2. And then to get to the y value, we just plug in f of 2. So we're going to plug 2 in for every x. Then we get our y coordinate. And so we get our vertex is 2, -5. To list the possible rational zeros, we do our plus or minus p over q. P is 12, q is 5, and so we write out all of the different fractions, make sure it's 1 over 1, 2 over 1, 3 over 1, and so on, and then 1 over 5, 2 over 5, 3 over 5, and we see all those fractions listed here. To find the solution for this one, all we have to do is plug these answers in. You do not have to solve this system. You can just do process of elimination, start with one of them and plug them in for all the x, y's, and z's and see which one of these options makes all 3 of these true. And luckily for us, it was the very first option that we tried. For number 14, they gave us the graph of f of x, but then they asked us all these questions about inverse. So what you could do is look at the inverse points. So if you have 0, 1, the inverse would be 1, 0. If you have 1, 2, the inverse is 2, 1, and then 2, 4, inverse is 4, 2. So you could plot those points, or you could just list them out. So if they want f inverse, we're looking at these points. So when x is 4, what is y? Well, y is 2. And that's the only one out of these options that was true. So here we're converting, jumping into logs and exponentials. So remember, natural log is log base e. So this is e to the x equals a, to just circle around to convert. We're not solving anything. We're just rewriting it in a different form. Change of base is always the log of the big number divided by the log of the base. And remember, you could use log or natural log to do this conversion for change of base. More converting, so remember the base of your exponent is the base of your log, so we're going to be a log base e, so we know we can cross off these guys because the base of our exponent is e, so the base of our log has to be e. And we can also cancel out this guy because it's not a log base e. And so we're just left with b. Of course, any exponential function can be rewritten in logarithmic form. So that's all of the multiple choice, and then we have the show your work. So here we are completing the square to convert it into standard form. So we paired the x's together. First thing I did was I rearranged and put the x's together, and then the y's, and then completed the square. -4 divided by 2 squared is 4. 18 divided by 2 squared is 81. So we get x minus 2y plus 9. And then again, we have to make sure we balance the equation. So we have our circle in standard form there. Remember, take the square root of this to get your radius. X and y intercepts. For the x-intercept, you're plugging in 0 for y, solving out. For the y-intercept, you're plugging in 0 for x, solving out. Notice, when we take the square root, we do have a plus or minus, so you should have 2 y-intercepts. Keep going with transformations here. So it wants us to take the original function, which is just this random little rainbow guy here, and they want us to reflect it. That's why that negative is there, and then shift it to the left 3. So we take these original points and put them in our table of values. And we're going to reflect the y value. So notice we take all of our original y's and multiply them by negative, and then we have to move all of our x values to the left 3. Then we're going to plot the points, -2, -3 here, 1, -6 here, 4, -3 here. We can make our transformation accordingly. Here we have function operation, function composition, given a graph. So remember, f minus g of 1 is the same as f of 1. So f of 1 is 0. G of 1 is -2. So 0 minus a -2 is +2. Then we have composition, so we work inward. So we start with an x value of -1. We want g of -1. So g of -1 is -3. Plug that in here. Now we want f of that guy. So f of -3 is +1. Long division here, I'll just kind of zoom in. Feel free to pause to find your mistake if you didn't get it correct. And pay attention. Look at how we're always, you're kind of moving over, multiplying, and then subtracting, changing all of their signs. Things should be canceling. And then finally, when you get all the way over, your final answer is your remainder. So you want to write that over what you're dividing by. Remember to plug in placeholders where you need them. If we want to find all the zeros of a function, synthetic division is easiest, especially if they give you one of the zeros. So we take the coefficients 2, -3, -14, 15, divided by 3. Remember, drop it, multiply, add. We get a remainder of 0, which we know should have happened because they told us 3 was a 0. So it should have ended in 0. We're dividing because we want what's left over so that we can factor this quadratic to get the rest of the zeros. So all of the zeros are the 3 that they gave us, and then the -5/2 and the 1 that we got from solving the quadratic. Next, solving a system. So we have squared. So if you have x squares and y squares, you just eliminate one of them, and we get that x could be positive or -1. You have to take those separately. When x is +1, what could y be? Well, when x is +1, y could be +3 or -3. Then you do the same thing with -1. When x is -1, y can also be +3, -3. Because for both scenarios, you got the same y values, you can write it like this. Otherwise, you can give all 4 of these as your answer. Here, inverses, remember to find an inverse, first you have to switch x and y, and then solve for y. We did these a lot. We're going to multiply both sides by y plus 3, distribute the x's so that we can move the y's over. So in this case, I move the 2y over here, the 3x over here. They just kind of switch spots, factored out the y, and then divided by x minus 2. Depending on how, if you moved xy over here, your answer would be 3x, and then it would be, I think, 2 minus x in the denominator. Both of those would be correct. If we condense here, so the coefficients become the exponents. Notice the cubed and the 5. Anything that's adding, if the two logs are adding, we're going to multiply their values. And then anything that's subtracting is going to go in the denominator. So we condense there. And then finally, solving this exponential function, we want to rewrite it so that they have the same bases. So 8 is 2 cubed. 1/2 is 2 to the -1, and so then we just pair those with the exponents, and negative with the x plus 6 is -x minus 6. 3 times 2x plus 5 is 6x plus 15, and because these guys have the same bases, you can set the exponents equal to each other to solve. All right, guys, I hope that answered all your questions. Let's see how you did.